Okay, doing something a little bit different today. I wanted to go over something for even and odd functions. And what we want to find here is we're looking at cosh t or hyperbolic cosine and sinh t or hyperbolic sine. And we want to find out for both these, are these functions even or odd, or they could be neither. There's also functions that are neither even or odd, but we're just asked to find, are these even or odd? But before we get started with this, we need to look at a couple of formulas and definitions. Okay, so first we have over here to the right our definition of odd and even. So for an odd function, f of x, if we just plug in for our input minus x, we end up with just minus times the function we started with. And then if we have an even f of x, if we input minus x, the minus goes away and we just get back the function we started with, f of x. And then if you're not familiar with cosh and sinh, we have our definitions over here, and we can just write it in terms of exponential functions like we have here. So first we'll just start with our cosh. So we'll say if our f of x that we're going to deal with is just going to be cosh of x, and I can write it in terms of this definition, e to the x plus e to the minus x over 2. And to check if it's even or odd, all we need to do is look at f of minus x, and then we can just plug that in everywhere. So this becomes e to the minus x plus e to the minus, plugging in minus x again, over 2. Well, minus times minus here becomes plus. Then I can just reorder this and put the e to the x first and then the e to the minus x second, just to make it clear. But this here, this is actually the same thing as our definition of cosh. So this is actually just cosh x, but cosh x was our f of x. So what we're saying then is f of minus x equals f of x, and that's our definition here for even. So this means that this has to be an even function, so cosh is going to be even. Next we'll do the same exact thing, but we'll just do it for sinh. So for our f of x, we set our f of x equal to sinh, which is our definition that we have right here. And what we want to do is look at f of minus x. So then we'll plug in here. So we're going to have, this is going to become e to the minus x minus e to the minus x over 2. Again, minus times minus here is a plus. But now this doesn't quite look like either of these. What I can do actually is, what if I factor a minus out in front of this? So then if you do that, actually, let's just do it here. So if I factor a minus out here, then what's going to happen is this becomes a plus, this becomes a minus, and then let's just rewrite it so it's really clear. So we have our minus up front. This here is just e to the x. Then this one is minus e to the minus x over 2. But now this right here, just this is our sinh. So I can write this as minus sinh of x. But again, sinh of x is our f of x, so I can write this as minus f of x. But then we're saying that f of minus x equals minus f of x. That's our definition for odd. So then sinh is going to be odd. So one last thing before we end this, what if our f of x is tanh of x? Is tanh of x even or odd? Well, we can rewrite tanh as just sinh of x over cosh of x. And so since we've already done some of this work, I don't think we need to go all the way back to the definitions here. We can just do this from what we have. So I think what we'll do is we'll look at our f of minus x the same way we did for the others, and then we'll just plug in here. So we can look at this as sinh minus x over cosh minus x. But using what we found before, that sinh is odd, what that means is I can use the definition of odd and bring the minus sign out front. So we can write sinh of minus x as minus sinh of x. And then the same kind of idea on cosh, we already found that cosh is even. So we can use the definition of even. And then what that's going to do is the minus sign is just going to go away. So cosh of minus x, using this, is going to just be cosh of x. But now we have sinh over cosh. So this is actually just tanh. So we have minus tanh of x here. But tanh of x is our f of x. That's what we started with. So we actually have minus f of x, and this again is the definition of odd, so tanh is going to be odd. And so these three values, this is really easy to remember because they just are the exact same as what we find for the regular trig functions. Cosine is even, sine is odd, and tangent is odd. So it's an easy way to remember, but if you ever need to prove it, you can go back to these definitions and do it pretty quick. So that's it, just a little review of even and odd functions for the hyperbolic trig functions. Thanks everyone for watching. Have a good day.